Good morning all. Today we are going to discuss Pappus-Guldinus theorem. This is a very important theorem. There are mainly two theorems. First theorem is related with the generation of area and the second theorem is related with the generation of volume. So first theorem states that the area can be generated by revolving a plane curve about a non-intersecting axis in the plane of the curve and is equal to the product of the length of the curve and the distance travelled by the centroid of the curve while the surface is being generated. So second theorem, the volume can be generated by revolving a plane area about a non-intersecting axis and is equal to the product of the area and the distance travelled by the centroid of the plane area while the body is being generated. So this is a very important theorem in module 3. So now the second question, that is definition of moment of inertia, that is mass moment of inertia. So mass moment of inertia is defined as the second moment of the mass and it is denoted as I. I is equal to integral r square into dm. Its unit is kilogram meter square or kilogram centimeter square, and it is a property that measures the resistance of a body to angular acceleration. So now the third definition, that is radius of gyration. It is a distance such that its square multiplied by area will give the moment of inertia, and it is denoted as k. So I is equal to I is equal to a into k square, where k is equal to root of I by a. Its unit is meter, centimeter or millimeter. So now the next definition is moment of inertia. So radius of gyration is distance such that square multiplied by area give moment of inertia. So you can define moment of inertia. It is the second moment of area, which is a measure of resistance to bending. It is denoted by Ixx or Iyy. So here Ixx is the moment of inertia about the centroidal xx axis and is equal to integral y square into dE. And Iyy is the moment of inertia about the centroidal yy axis and is equal to integral x square into dA. And its unit is millimeter raised to 4, centimeter raised to 4 or meter raised to 4. So next is the polar moment of inertia. That is the moment of inertia about the z axis. You can calculate the polar moment of inertia using the perpendicular axis theorem, which we have discussed in the class. It is a measure of the beam ability to resist torsion. So Z is equal to Ixx plus Iyy. It is according to the perpendicular axis theorem. So its unit is centimeter raised to 4, millimeter raised to 4 or meter raised to 4, which is same as that of the moment of inertia. So next important theorems in module 3, that is differentiate centroid and center of gravity. You can refer to the PPT of centroid. Next is the parallel axis theorem and perpendicular axis theorem that we have discussed in the class. You can refer to the PPT of moment of inertia. So while writing the statement, you have to write the statement correctly and then you have to draw the figure and include all the equations. So there is no need to explain the figure. Next is a very important topic from module 4. That is write a note on normal and tangential acceleration. So when a body is moving along a curved track, velocity changes both in magnitude and direction. So the acceleration due to change in magnitude of velocity, that is known as the tangential acceleration, which is denoted as a t. That is equal to dv by dt. So now the acceleration due to change in direction of velocity, that is known as the normal acceleration, which is denoted as an. It is directed towards the center of rotation. An is equal to v square by r. So after getting at and an, you have to calculate the total acceleration which is given by an plus at. So here while doing the problems you have to calculate a total is equal to root of an square plus at square. So this is the equation for total acceleration. And when the particle is moving along a circular path with a uniform velocity, tangential component of acceleration is 0, and when the particle is moving along a straight path, normal component of acceleration is 0. So this is a very important question. We have discussed this in your class. So next is the problems related with normal and tangential acceleration. So here you can see a car start from rest on a curved road. So you can identify the question using this term, that is curved road. A car starts from rest on a curved road and the radius is given as 250 meter, which attains a speed 18 km per hour at the end of 60 seconds while traveling with uniform acceleration. And you have to calculate the tangential and normal acceleration of the car 30 seconds after it starts. So initially the car is starting from rest. So initial velocity is equal to 0. Final velocity after 60 seconds, that is equal to 18 km per hour. So Vf you can calculate as 18 km per hour, that is converted to meter per second. So 18 into 5 by 18, that is equal to 5 meter per second. So you can calculate the tangential acceleration. Tangential acceleration at is equal to Vf minus V0 by t, that is equal to 1 by 12. So this is the tangential acceleration during the travel. So now the velocity at the end of 30 seconds you have to calculate, because you have to calculate normal acceleration, that is changing when the direction changes. So initial velocity is again 0. Acceleration, that is the tangential acceleration, is 1 by 12 and time is equal to 30 seconds. So Vf is equal to V0 plus A into t. From that you are getting Vf is equal to 5 by 2 meter per second. So after getting the acceleration velocity, you can calculate the normal acceleration. Normal acceleration at the end of 30 seconds, that is equal to Vf dash square by r. You have to use this velocity, that is equal to 0.25 meter per second squared. Then you have to calculate the total acceleration. Total acceleration is equal to at square plus an square, that is equal to 0.87 meter per second squared. So if you after calculating the total acceleration, you can calculate the direction of total acceleration, that is using the equation tan theta is equal to an by at. So now the next question. The train runs at a speed of 120 km per hour in a curved track of radius 900 meter. So here again the question, it is specified the body is moving along a curved track and the radius is given as 900 meter. Application of brake suddenly causes the train to slow down at a constant rate. After 6 seconds the speed is reduced to 72 km per hour. Determine the total acceleration. So initial velocity is given as 120 km per hour and final velocity is 72 km per hour after 6 seconds. So you have to convert into meter per second. VO is equal to 33.33, Vf is equal to 20 meter per second and the tangential acceleration is equal to Vf minus V0 by t, that is equal to 33.33 minus 20 by 6, that is equal to minus 2.22 meter per second squared. So now immediately after the brake is applied, so here you have to note this condition. So immediately after the brake is applied, we have to choose the velocity for calculating normal acceleration as equal to 33.33, that is the initial velocity. So that point you have to remember. So an is equal to v square by r, that is equal to 1.235 meter per second. After calculating the normal acceleration, you can calculate total acceleration and its direction. So now the next question, a car is moving at 72 km per hour and the wheel are given a diameter of 75 centimeter. So initial velocity is given as 72, diameter of the wheel is 75. Find the angular velocity, and we have already discussed the relation connecting angular velocity and linear velocity, and also angular acceleration and linear acceleration. So here you are given the angular velocity as the linear velocity as equal to 72 km per hour. You have to convert that into meter per second. So you will get the linear velocity as equal to 20 meter per second. So using that value, you can calculate omega. Omega is equal to V by R, 20 by 75 centimeter is the diameter of the wheel. So you have to get the radius, 75 by 2. That is equal to 0.375. Omega is equal to 53.3 radian per second. So that is the first part. Second part is, if the car comes to rest in a distance of 20 meter, find the uniform retardation. Also calculate the angular retardation. So you can use the equation of motion. Initial velocity is 20 meter per second. Final velocity is 0. Displacement is given as 20 meter. So you can calculate the acceleration using this equation. Acceleration is equal to minus 10 meter per second square. So now the relation connecting angular acceleration and linear acceleration, that is alpha is equal to a by r. So from this relation you will get the value for alpha, that is angular acceleration, is minus 26.7 radian per second squared. So this is a 3-mark question. So all these questions are from module 4. So now we will discuss the problems in module 5, which is we are going to apply the D'Alembert's principle in rotational motion. So this is the equation connecting D'Alembert's principle in rotational motion, that is T minus I alpha is equal to 0. So in linear motion we have D'Alembert's principle. In that we have the equation F minus ma is equal to 0. So here we are using the condition T minus I alpha is equal to 0. So this is a question from module 5. So here while reading the question, you can identify from the module 5 the question, if the mass of the pulley is given and its radius is also given, then you have to apply D'Alembert's principle. So here a pulley of mass 40 kg and radius 0.6 meter carries a weight 600 Newton suspended by a string wound around a pulley. Calculate the acceleration and tension in the string. So here the figure is not given in the question, you have to draw the figure. So mass is given as 40 kg, radius is given as 0.6 meter, and a weight is suspended from the pulley, that is equal to 600 Newton. So this is how you have to draw the figure. So while dealing with this type of problems, we are giving the notation for torque as equal to T, because we are using T for the torque in rotational motion. So the tension along the string is given another notation, that is S. So first step is you have to draw the free body diagram of the pulley. This carries marks, so you have to draw the free body diagram of the pulley. So this is the figure showing the free body diagram of pulley. It is holding a weight 600 Newton. So tension is acting in the downward direction, that is S. So now from the figure you can write the torque developed. Torque developed is equal to tension in the string into the radius S into 0.6. So now you have to apply the D'Alembert's principle in rotational motion. So T minus I alpha is equal to 0. So here we have to assume I is equal to m into r square by 2. So for a pulley we have to assume the moment of inertia of the disc. Moment of inertia of disc about z axis, that is equal to mr square by 2. So here you have to rewrite this equation as T is equal to I alpha. Again T is equal to S into 0.6. Equating these two equations, from this equation you can write instead of alpha A by R. So now from this equation you can calculate A as equal to 0.05 into S. So after analyzing the pulley you have to consider the linear motion of the block. Block is moving in the downward direction. So inertia force, that is MA, is acting in the upward direction. Weight of the pulley is acting downward. Tension along the string is acting upward. So next you have to write the net force in the direction of motion. Net force in the direction of motion is 600 minus S. Next you have to apply D'Alembert's principle related with the linear motion. Linear motion, D'Alembert's principle is F minus ma is equal to 0. That is net force. F is the net force. So net force minus ma is equal to 0. That is 600 minus S minus ma is equal to 0. So from this equation you are getting S as equal to 147.85. After getting this you can substitute in the previous equation to get the acceleration. A is equal to 0.05 S, that is equal to 7.29 meter per second squared. So now in the next question, a circular disc of radius 30 cm and weight 145 Newton is rotating about the geometric axis. A flexible cord carrying a weight Q is equal to 45 Newton is wound around the circumference of the disc. If weight Q is released from rest, find first one the time required for it to fall through a height 300 cm, and the second one with what velocity it will strike the floor. So this is a university question. You are given the figure. So weight Q is suspended from a circular disc, and you have to calculate the time required to fall through a height h is equal to 300 cm. So this height is given as 300 cm and the floor level is also given. So first step is you have to start with the rotational motion of the disc. We have to assume S as the tension along the string and T as the torque. First step is you have to write the equation for D'Alembert's principle. That is T minus I alpha is equal to 0. So here T is equal to I into alpha. So here you can see in the question weight of the disc is given. So you have to calculate the mass. Mass is equal to 145 Newton divided by 9.81. So now after getting the mass, you have to calculate the mass moment of inertia. That is, I is equal to mr square by 2. It is given that this moment of inertia is mr square by 2. So here the diameter is given as, sorry, the radius is given as 30 centimeters. So you have to convert into meter. That is, 30 centimeter is equal to 0.3 meter. So now the next step is you have to draw the free body diagram of the disc. So here the tension is acting in the downward direction. Radius of the disc is 0.3. So torque T is equal to S into R. So now this is your equation 2. You have to equate equation 1 and 2. Equating 1 and 2, you will get the relation connecting A and S. So now you have to consider the linear motion of the block. So you have to consider the movement of the block. So weight of the block is acting downward, tension is in the upward direction, weight is moving in the downward direction. So net force in the direction of motion is 45 minus S. So now applying the D'Alembert's principle in linear motion, that is F minus ma is equal to 0. Here F is the net force, 45 minus S minus m into A. M is equal to 45 by 9.81 into acceleration. Acceleration is equal to 0.13 s. So from this equation you will get s is equal to 28. So after getting s, you can calculate the linear acceleration, that is equal to 3.664 meter per second square. So now the first step is, so now the next step is you have to calculate the time taken. We have to use the equations of motion. So using the first equation of motion, V is equal to U plus AT. Whereas 4.7 is equal to 0 plus 3.664 into T. That is equal to 1.28. After getting the time, you have to calculate the velocity also. Sorry, first step is you have to calculate the velocity. Velocity V square is equal to U square plus 2AS. From that equation you will get the final velocity as 4.7. So after calculating this velocity, you have to use the first equation of motion. V is equal to U plus AT. That is, from this equation, time is equal to 1.28 seconds. So now the next question, a cage weighing 2940 Newton is raised by a rope, one end of which is wrapped around a drum, 120 centimeter in diameter and weighing 735 Newton and having radius of gyration 55 centimeter, which exert a constant torque 4000 Newton meter. So if the rope is tight, when the drum begins to rotate, you have to determine the acceleration, tension and the time required to raise the cage 20 meter from the ground. Neglect the loss of energy due to friction and weight of the rope. You can assume G is equal to 9.81. So here the figure is given in the question. So drum is having a diameter 120 and it is raising a weight 2940 Newton. So first step is you have to consider the rotational motion of the drum. You have to apply the D'Alembert's principle. T minus I alpha is equal to 0. T is equal to I into alpha. So here the drum is rotated by an electric motor which exerts a constant torque of 4000 Newton meter in the upward direction. So that is why the cage gets lifted up. But due to the tension in the string, torque is acting in the downward direction. And the torque due to the tension in the string is equal to P into 0.6. So here instead of S we are using P, that is the notation given in this question. So in the previous cases we have torque T is equal to S into radius. So here instead of S we are using P, so P into 0.6. So here the net torque is equal to, so this step you have to remember. So here along with the tension torque in the string, you are having an additional torque provided by the electric motor. So net torque is equal to 4000 minus 0.6 P, that is equal to I into alpha. That is the difference you see in this problem. So now the equation is 4000 minus 0.6 P is equal to 735 divided by 9.81. You have to assume 9.81 into 0.55 square into A by 0.6. So now that is the first equation. Second step is you have to consider linear motion of the block. So here the weight is acting downward and tension along the string is taken as P, that is acting in the upward direction. So here the weight is moving up. So net force in the direction of motion is equal to P minus W, that is equal to P minus 2940. So applying the D'Alembert's principle, net force minus Ma is equal to 0. So P minus 2940 is equal to 2940 by 9.81. You have to substitute 9.81 into A. So in order to solve this equation, you have to multiply equation 2 with 0.6. So equation changes to this one, and then adding equation 1 and 3, you will get the acceleration as equal to 10.265, and P, that is the tension along the string, is equal to 6019.5 Newton. So now next is the theory questions in module 4 and 5. So question number 5, state D'Alembert's principle. So state D'Alembert's principle, that is a question asked in module 4. So here the equation is F minus Ma is equal to 0, and you have to write this statement. So next question number 6. This is a question asked in module 5. State D'Alembert's principle and rigid body. So that is T minus I alpha is equal to 0. That is equation you have to write in question number 6. That is D'Alembert's principle in rotational motion or D'Alembert's principle in rigid body. And you have to write the statement also.